All right, hello, welcome everybody. My name is Balazs Bezi, and we are here with the platform development update on the 1st of November, and we are planning this session for 1 hour or less than 1 hour, depending on your questions and feedbacks as well. And we will have a dedicated QA at the very end, so please feel free to give us your questions and feedbacks in the live channel, in the live chat of the streaming. So we will have 4 teams today, and everybody enjoy it. So without further ado, please welcome Lukasz from the TenderDash team.
Hi, so basically in terms of TenderDash, we are finishing with the same block execution right now, and we are on the integration level. And when it comes to big features in TenderDash, I think that's the last one. So we can say that we are more or less feature complete. So we have a few smaller tasks to handle. Yeah. We have a few smaller tasks to handle. We have some stability issues and stuff like that. But besides that, we don't expect big changes in the source code. And what we did this sprint, so we spent some time on integration of same block execution with Drive, which is still in progress on both sides, but we just handled a few items and improvements that were needed in order to make everything work smoothly. Also, we have that task to have a better proof signatures for light clients to make proof validation and verification easier, which is in review right now. So maybe some review feedback will be applied and this will be also done in a few days. And big topic that we are doing right now is the stability, which is here denoted as deadlock investigation. We found one deadlock, fixed that, but others, at least one more is there, so we are on it. And that's it of what we did and what we have on our to-do list for now. So what's next? We need to finalize the integration. We need to do that review of the better proof signatures and some stabilization of flaky tests and bug fixes, improvements, cleanup of the code, like removing unneeded info from Genesis documents, some bugs that we have hit on testnet and that need to be fixed before the release. But that's more improvement than the new feature. So that's where we are right now. And that's more or less it on my side.
Thank you very much. Let's continue with GroveDB.
Hey guys, my name is Wisdom. I'm an engineer on the GroveDB team. So the goal for the sprint was to finish cost and finish some trades. So Balazs, can you go to the next slide? Thank you. So last time we had an issue with batches when it comes to some trades, but then we were able to resolve that, and then we had a PR for some trades. But now we are merging the PR with cost to make sure that it works with that PR, with that branch, and then we'll have another review. So once cost is merged, then some trades will be merged after. So I pass it on to Sam to talk about cost.
Yeah, thanks, Wisdom. So yes, so for costs, we had a lot of stuff that we were talking about last week about what was needed still for costs in GroveDB. I want to be very happily report that it's all done finally, and that GroveDB has a pull request that is open for costs. So one of the big items was the removal of the root tree storage. So that's all in review at this point. There were many things to deal with when dealing with root tree storage removal. And I'll quickly explain what root tree storage removal is that for every GroveDB is actually a layered, it's a multi-dimensional tree that has layers of binary trees, binary Merkleized trees. And on each layer, at the root of every layer, before we were storing information about that layer. Now, instead of storing information about that layer in some storage somewhere, it's actually stored on the tree above. And storing it on the tree above severely reduces the amount of space that's needed, and also allows the system to achieve something that I'm calling node independence, where each node in the system actually pays for itself, and there's no additional storage for storage costs for the system at large. So anyways, it's done. That was very hard, and we can go to the next slide. So as I said, costs are done. One big item that was very complicated was the deletion cost. So when it's actually not so much a cost as it is a reimbursement. The issue with that is that there are multiple problems with deletion costs. First, when you delete something, it's not like when you put something. When you put something, you know how much data you're putting. When you're deleting something, you actually have to load the node and then remove the amount of data that the node costs. Now, this is actually fine for items that you're putting in your tree, but as I said, GroveDB is a layered tree, and we have three types of nodes. One of them is an item that just stores information, like, let's say you were going to put a contract, and inside the contract you have a car, right? And you put your car in the database storage, virtual car. Well, that would be an item. Then we have something called a reference. Let's say you create a way to query the car, and your car is red, and you want to say, give me all cars that are red. Well, there'd be a reference saying that your car is red somewhere in the in GroveDB. That's the reference type. The third type are trees themselves. So it's, as I said, GroveDB is a layered Merkleized structure, so multidimensional. Basically, we call them tree nodes. The tree nodes have basically another layer. They are the thing that that allows the layers to communicate between each other, and they also have specialized costs, and they have specialized costs for deletion. So deletion of these layers are extremely complicated, but I'm happy to report it's done. If I don't know if what I just said makes sense to anybody, I don't really. It's not super easy to explain. So you did talk about specialized tree costs, identity epoch removal costs. Yes. So when you remove data from the system, let's imagine in the case of, I put my car item and now I no longer use it. So you can actually remove the item from the system along with its references. And at that point, you basically get the storage cost back. One really cool thing about Platform is that you can add stuff as storage, and then you can remove stuff, add stuff, remove stuff. And this allows the fees to be extremely low, because when you remove it, you basically get 99% of your storage costs back, and you're only paying for one epoch. One epoch is 18 days. So the amount that you're paying for the storage costs goes down incredibly, which would allow Platform to be used for things like games, right? Where you have to store information, but you don't want to store it, like, it doesn't matter that you store it for a very long time. So yeah, that's what the problem is that when you remove stuff from the state, you have to make sure that you're not giving back identity is too much money. So each node actually has a reference to when it was originally inserted. And it also knows based off of its size how much it costs. So when you remove it, you actually go back to the you can calculate how much funds are given back to an identity. That's done. Free root layer root cost. Yeah. One interesting part of the system is that there is one storage root cost that has to somewhat be paid for, and that is the first root. The first root is basically the one at the genesis of the chain. And well, we don't need to really deal with that because the genesis of the chain is only going to happen once and it's going to cost like 1 cent. So instead of creating a lot of complicated code to deal with this 1 penny, we instead make that 1 penny free at genesis. So, but it did require a little bit of work. So worst case storage costs, that was also done. Worst case storage costs are basically what is the worst case when you insert an item, and this is state independent. So this you'll always know the storage costs of something that you insert. Now, we also have worst case processing costs. We have decided for the first release to, instead of doing worst case processing costs, to instead use something called average case processing costs. And the reason for that is that the worst case processing costs are not representative of the actual cost that you're going to pay. So, you know, we're doing it in a much smarter way than I think we originally planned, and a much simpler way as well. Okay, so now we have insert, update, delete, batch operations. Yeah, that's all in review as well for costs. Okay, next slide, please. Yeah, so people have been asking about tests about GroveDB, and I just want to explain that, you know, it is extremely well tested. For GroveDB, so GroveDB has sub-projects inside of it, and it's basically using, you know, one project uses another project, uses another project, uses another project. So GroveDB uses Merk, Merk uses storage, and actually all of them use cost package. And GroveDB has 161 tests. Merk has 172 tests. Storage has 18 and cost has 10. Then we have docs that are automatically generated, and they also have subtests. Next slide, please. Yeah. Okay. So what is this equal to code coverage? So code coverage, for people who don't know, is how much of your code is tested. Like every line, how much does it actually get represented in tests? And a good code coverage is something above 60% generally. And for GroveDB, you know, it's very, very high. I ran this yesterday expecting something like 60 to 70%. And instead we got 87% for, you know, the GroveDB sub package and 92% for the Merk sub package. So it's just very, very high. And when we actually look inside to see what is not code tested, well, it's mostly the tests themselves. So like functions that are used for the tests, like visualize output errors, right? And so you don't actually use them all the time. And that's why they're untested. They're not actually in production, or things that are used for benchmarks or things like that. So, you know, we have very, very high code coverage, and it's great. And that's pretty much it. So where we're at with GroveDB is that with fees, you know, it currently is in review. The pull request was like 14,000 lines of code. With that being, when that's done being reviewed, and with the the sum tree is right on top of it, we will be very close to being feature complete. At that point, we just have a little bit of work with average case processing costs, which is pretty small, maybe 1 or 2 days. And then we have to continue the integration of GroveDB with platform, which is not actually a GroveDB task. It's more of a protocol task. So, we're already working on that. And then we need to write better documentation for GroveDB. So, we're very close to being done with GroveDB for mainnet release. So I'm extremely happy where we're at right now. And with that, I will not pass it on to Igor because Igor is off and is coming back next week. So we are going to skip SDK today, and we are going to go straight to protocol. So I believe I'm handing it, well, who am I handing it to?
Javid.
David, go.
Hello, everyone. So first of all, I would like to share the goals for protocol team this sprint, which are same block execution, multiple transactions, and continuation of our work for withdrawals. Next slide, please. So first of all, I will hand it over to Kostya to share the progress about on same block execution. Kostya, would you mind?
Yeah, hi everyone. So as we said in our previous reviews, we are moving from the next block execution tender dash model to the same block execution model. And tender dash part is ready, and in Drive, let's say the main part is done. It basically works, all tests are green, and we just need to review it once again and merge the code together. And the next part of implementing this model will be adding multiple transactions. This is what we will do next. I think Javid will talk about it a little bit more. Javid?
Thank you, Kostya. So quick recap of the previous sprint task we had in progress. And this is deploying of the Dash platform v23 alpha as well as core 18.1. It is currently deployed on testnet, and judging by the CI and tests run, platform is feeling good, and it is deployed and fine. So that's great to have. The next thing is multi-transaction support in Drive. This is required by same block execution because during the same block execution, we will be having multiple rounds of proposals, and only one of them will be accepted. So we should run the processing into different inside of the different transactions, and only one transaction will be committed, and the rest of them will be aborted. This work is done, so Kostya is now continuing integrating this into his work for same block execution. The next one is a part of a preparation for the next release of the core, because there were some changes with wallet processing in core. They no longer creating it for you, so we just updated platform to the Dashmate package to create a wallet for system needs, and it's now integrated, and we're safe on that front. The next one is, so we previously had a task which we're calling withdrawal resets, so we can kind of reset the withdrawal that's been sent to the system. But now we're moving on to a system which will be tracking the status of these withdrawals by using a system data contract and a withdrawal document, which will be having all the withdrawal information as well as the status field, which will be used to track on which stage the withdrawal is currently in. And this, based on that, the system will be either recreating a new withdrawal or letting you know that that the transaction is no longer is not actually on chain and haven't been there for some time. This work is currently in progress because we're refining some parts regarding the watchers that will be watching this statuses and processing code. But the work, which is, we actually created a package for system data contract for withdrawals already. And right now are working on integrating some bits and parts into identity credit withdrawal transactions. So this will be working on its own. That's it regarding withdrawal status tracking. And we have Rust binding for BLS signature, which is currently still in progress. So there's nothing special about it. It's just, I believe it was a bit delayed by I've been working on withdrawal status tracking documentation and whole thing with processing. So next slide, please. All right, so what's next? First of all, it's continuation on work on fee system by integrating some new GroveDB costs. Sam actually mentioned in his presentation on GroveDB. It's continuation of the work on withdrawals, so we're still in progress and we will be doing that and focusing on that. Continuing work on VLS Rust bindings and continuing to work on same block execution, but on the part which we will be using these multiple transactions which are already implemented. So that's it. Thank you.
Thank you very much. Thank you very much, Javi. Great work.
I should hand it to Anton, right?
Yes.
Hey guys, Anton's here, and today I'm going to give you a little update on our Rust porting efforts, namely the Dash platform protocol Rust port effort. So last time I mentioned that we were porting the BLS changes from Core V18 and generally making Core V19 compatible with our JavaScript deployment tools. It was kind of a part of porting BLS changes as well. So we've done with it. Deployment tool works so far. It supports new RPCs for wallets that will be introduced in 18.2, I think. Also, now all the deployment tools support version 19 of Core, which is not yet released as of now, which is an upcoming version of Dash D. So we're still working on integrating Rust DPP into the rest of the platform, and this is going to take some time still because there is a lot of work to do, and there's a lot of packages and projects, all the backend stuff, Drive, DAPI, all those things that we need to integrate our newly ported DPP into. So that's still going to take a while before that. And one major problem, one major challenge that we was facing this sprint is that a lot of stuff in Rust ecosystem isn't necessarily directly compatible with our old implementation. Like, for example, since in platform, we allow people to create a contract that contain regexes for their own string validations and things like that. Regexes are not safe to run on the backend in general because they can have they can stall the processes and stuff like that if it's especially if it's a regular expression that contains some backtracking and stuff like that. And we've discovered that a lot of stuff that we made previously in our previous JavaScript implementation isn't really compatible with Rust due to differences in libraries and stuff. And we were working on either bringing the libraries we've used before, which mostly are C++ libraries, into our Rust code base and creating this chain of plugging C++ into Rust, and then plugging Rust into JavaScript, which turned out to be quite a challenge. And so then we changed course a little bit to discovering new libraries to deal with these issues. And it seems that those are possible to resolve without making any more research on how to plug all this complex chain of dependencies into WASM. And instead we can just use Rust native implementations for the important things, but that's still in progress. I can't say that it's finished. We're still investigating on that front right now. So that is an update on Rust DVB porting effort. Thank you, everybody.
All right. Thank you very much. And thank you all the teams presenting today. We have one question unanswered, so if we can go to the questions or the Q&A part. Will you be releasing the latest version of DashPay for testing soon?
Yeah, I was just asking Brian, but I don't have an answer yet. So I honestly, I do not know. Does anybody here know? I don't think so. So, you know, I'm the reality is that while it probably was said to me that when we were going to do this, if I tell you guys right now a date, I might get it wrong. So let's wait for Brian who is our head of product, to tell us when exactly we are releasing the latest version for testing.
All right. Is there any way that we can communicate that as well? I mean,
yeah.
on Discord, having an announcement or something like this?
Yeah,
or
sure.
I mean, DashDev or some.
I'll put it in the general channel of Discord right out as soon as I get an answer from Brian.
All right. Cool.
Oh, is it next week, James Doe? You might know better.
All right. Is there any other questions or feedbacks or anything that you would like to share with us? All right. If you have, please feel free to.
There was one question on the Discord.
Yes.
Very quickly that somebody asked, and I'm going to answer really quickly. Somebody was asking, this is a high performance masternode question, and they were just asking it, and I said I'd answer in this call. They were asking, why does a 1K optional high performance masternode system not work, or can it work? And I wanted to quickly answer this. We are going to have an FAQ later this week on that, but very quickly, imagine that you have money given to the nodes running platform and core, and you have money given to the nodes running core. Well, since you have more money given to the nodes running platform and core, there's always a disadvantage for the nodes running just core, because they use the same collateral. There is no market equilibrium that can happen. So you're always putting the nodes not running platform at a disadvantage. So let's imagine, okay, we only want to reward the nodes running platform a little bit extra. We only want to give them a little incentive because we don't want to disadvantage nodes running core that much. Well, okay, you give them like maybe a 10% or 20% of the block reward. So it's just a little advantage. The issue there is that since the advantage is really low, you're not going to get that many nodes actually participating because maybe it's just not worth it for them. You can't actually know. And what could happen is the nodes that have a lot of Dash would participate more, and you can get into a system that's extremely centralized because there is no market equilibrium. Because let's imagine at that point, let's say only 600 1K nodes run platform, but you have, one entity that can run 200 nodes. Well, now you have one entity that can have 1/3 of all nodes in platform. So it's really very risky and very potentially centralized. When we were talking about the 4K and 10K high performance masternode solutions, at 4K you're actually rewarding platform. You don't have this extra, right? So it always, because there's a difference between 4K and 1K, the more nodes actually leaving core to go into 4K, the rewards from core go up, whereas the rewards for platform go down. So you get this market equilibrium that goes into play. So by rewarding platform more, it just means that there are less nodes running core. And that's where, you get this market equilibrium that comes into play, and you can reward platform a lot more. And by rewarding platform more, you also get a higher proof that at market equilibrium, the amount, the centralization goes way down compared to the other solutions. So it's hard to understand on the first try. It's a hard concepts. The FAQ should help with these topics, and we are going to be providing the FAQ later this week.
Thank you very much. All right. If no further question, I would like to thank everybody for being here, having questions, giving us comments and feedback, and see you in 2 weeks.
You guys.
Bye-bye.